Okay, welcome back. We're in part 5 circles in analytical geometry, and we've been completing the square, just working on some algebra. And let's bring that algebra back to our pictures and our circles of why we're completing the square. How does that relate to circles and the center and the radius? Okay, so let's jump into some examples. Write 2x squared minus 4x plus 2y squared equals all of those things in center radius form. So let's just pause and remind ourselves, center radius form is to write our circle in this way. Y minus b squared equals r squared. This tells us that the center is at AB and that the radius is r. So our center is at coordinates AB and our radius is r. So if we can turn it into that nice standard form, we can read off our center and our radius. We might even be able to draw our circle. Okay, so first things first, I can see 2 goes into everything in this equation. So I'm going to divide the entire equation. I'm just going to do that so we can see where we are. Divide the entire equation by 2 minus 2x plus y squared plus 10y equals minus 17. And at the same time, I've made sure I've got all my x's and y's on one side, right? Because that's where we need to work with them. So x squared minus 2x plus y squared, this minus 20y, I've added 20y to both sides and divided by 2. And this negative 34 I've left here and divided by 2. Okay, so what we need to do is turn this into something like this. Notice I'm giving myself a bit of a gap. Okay, so we know that that's going to be x. I propose that that's minus 1. Because if we kind of thought what x minus 1 squared is, well, it's x minus 1 times x minus 1, which is x squared minus 2x plus 1. So see how that minus 2x is what we had? Notice that we've got negative 2 and just divided it by 2 to get negative 1. Okay, but 1 squared gives us 1, so we need to subtract 1. So pause for a second as you need be and check algebraically that that is the same as that. Should be. As you multiply it out, we haven't changed anything. Those two things must be equal to each other. Okay, now let's do the same for the second one. So I'm going to say it's y plus 5. Why y plus 5? Well, I can imagine in the background this being y plus 5 times y plus 5. I know that I'm going to have the y squared, and 5y plus 5y gives me the 10y. So this 10y is double this number here. And if I multiply this out, I'd have plus 25, but we didn't have a plus 25 at first, so I'm going to subtract 25 to compensate for it. Okay, we're not quite in center radius form. We needed to look a little bit more like this. Well, minus 1 minus 25 is minus 26. And let's just check. Well, we need to add 26 to both sides. So 26 plus minus 17, I think gives us 9. So we've got a 9. Okay, so now that it's in center radius form, we can read off that the center is at 1 minus 5. Because this is like our a value, and this is like subtracting negative 5, which is our b value. And our radius, well, our radius squared is 9, so our radius is 3. Okay, so there's some thinking on completing the square. Let's do a few more examples. In fact, before we do an example, I thought, let's draw this circle quickly. So we know that the center is at 1 minus 5, and we know that the radius is 3. So we can draw it something like that. And I'm completely in the way, aren't I? Okay, so there's our circle. Rough sketches just for now of what your circle looks like. Okay, next example. Determine the center and radius of the circle with the equation that. In other words, complete the square so that we can work out what the center and radius are. So it might be easier if we write it in this order. Plus 8x plus y squared minus 3y plus 6 equals 0. Or you might have wanted to say, no, all the other ones had something like that. Doesn't really matter. Okay, complete the square. Pop a pause as you need to, because I'm going to just go for it straight away over here. And I guess I should have left a little bit of space here because I'm going to have to compensate. So I'm going to go for it. Pause if you need to. Okay. X plus 4 minus 16. Y minus 3 over 2. Minus 9 over 4. Okay. So hopefully that was the idea. X plus 4 squared gives us x squared plus 8x plus 16. I need to subtract 16. Minus 3 divided by 2 is minus 3 over 2. So if I multiply this together, it would be y squared minus 2 of these 3 over 2's. And I would have plus 9 over 4, so I need to compensate. Okay, not quite in center radius form. Plus y minus 3 over 2 squared equals, well, we've got negative 16 minus 9 over 4. Oh, that's not what I wanted. I wanted the calculator here. And let's have a look here. Oh, that's rather exciting. Okay, that looks a bit better. So we've got minus 6, and we need to add 16, and we need to add 9 over 4. 49 over 4. Definitely want to leave this as a nice improper fraction there. And the reason is we can now read off our center and our radius quite easily. Well, our center is, I think of those minuses, minus 4, 3 over 2, and our radius is the square root of that, which, because we left it as a nice improper fraction, it was easy to find. And of course, we could sketch our circle as well, but I'd rather just keep going with our other examples. Okay, determine the center and radius of the circle. In other words, keep completing the square, complete the square, complete the square. So 2x squared plus 6x plus 2y squared. I'm going to just put this equals 5 on the other side because we don't need it just yet. Okay, 2x squared. Well, we need to divide everything by 2 because we're always going to make sure that we don't have a coefficient of x squared or of y squared. Plus y squared equals 5. Okay, so pause as you need to so that you can complete the square. Okay, well, this is plus 3 over 2. And I need to have a minus 9 over 4, because 3 over 2 all squared is 9 over 4, plus that's already a nice perfect square. So I'm not going to do anything. Or you could think of it like this, y minus 0 squared. Right? Okay, so I'm going to leave it as y squared. Seems overly complicated otherwise. So x plus 3 over 2 squared plus y squared equals 5 plus 9 over 4. Let's get our friend up here. 5 plus 9 over 4. 29 over 4. 29 over 4. So our center is at minus 3 over 2. Y value? Well, 0, because it's like y minus 0. And our radius is the square root of that. We could have just said the square root of that. Well, the square root of 4 is 2. Okay, so one last merry example. Determine the equation of the circle with center that passing through that point. Okay, so we know that the general form of a circle is x minus a squared plus y minus b squared equals r squared, right? That's what we're slowly getting comfortable with. Okay, the center is 3 minus 4. So x minus 3, because that's the x value, plus y minus minus 4 equals r squared. Okay, well, we know that it's there, but we've got a point. So wouldn't it be easiest if we just substituted this point in? We know that this equation is always true for any point on the circle. We know that it goes through 0, minus 2. So we can just substitute that in. 3 squared, I think, is 9. 2 squared is 13. So 9 plus... Oh, I think that 2 squared is 4, and I'm jumping ahead. This is 9, right? This is 2, and no, this is not 2. This is 2 squared. 9 plus 4 is 13. In other words, 13 equals r squared. It said determine the equation. So we know that we must have x minus a squared plus y minus b squared. So that was that minus 4 equals r squared. So that's why I didn't take the square root of each side, because I knew that the right hand side was r squared. Okay, and we're going to draw some nice circle there, but I think that's enough, and that's the end of part 5. So enjoy exercise 5. There are the questions to do. For each of them, draw a little sketch as well, just to start getting into it, just to see if it kind of matches up with what you're thinking. Okay, that's it. I'll see you in the next part.